Hello everyone, welcome to the tutorial on the vertical jump analysis program. So the first thing that we want to do is we want to select a file to analyze. So we're going to go to File, select Load File, and then one thing you have to be a little careful about is when you save a file from the AccuPower program, when you originally collected the data, you want to make sure that you save it as a .csv file. So this program can only recognize .csv files. So I'm going to choose a counter movement jump file that was created. I'll double click on it. Notice that it'll plot the entire vertical force over time. The data looks a little noisy, so one thing I want to do is I want to filter the data. So to do that, I'm going to choose Filter Data, choose Cutoff Frequency, and this is a low-pass Butterworth filter. I'm going to choose 24 Hertz as my cutoff frequency, and I'll hit OK. So it smooths the data a little bit. Okay, the next thing you want to do is you want to select a region to compute the individual's body weight. So we know that when you're standing still at the beginning of the jump, the force is going to be pretty much plateaued, and that is going to equal to their body weight. So I'm going to select a region up front where it's plateaued. So let's say from this point to that point, and notice the beginning and end of where I selected, those are going to appear in the beginning time and the end time little windows here. So the 1.527 seconds, that was the begin time. The 2.883 seconds was the end time. I will hit calculate weight, and I receive the person's body weight in newtons, so 849.6 newtons. And notice also I keep a running tab here of the computed variables, so we know that the weight was computed. The other thing that I have the program do is I have it to try and estimate the beginning of the jump and also when the person is in the air. So when they leave the force platform and when they land back on the force platform. So that's what these red circles are. So this first red circle is the beginning of the jump, right, when the force goes just below body weight, and that time is listed here, so 5.368 seconds at that time. And then the interval in air, these two times correspond to these 2 points when the person's in the air. So this first red circle right here is when the person just leaves the force platform, right, when the force becomes 0. And then the second one is right when they land on the force platform again. Okay, so those may be useful later on. So let's say we want to first compute the jump height using this information of when the person was in the air, the time when they're in the air. So I'm going to highlight this region, click zoom in. Notice when I do that, right, again, the beginning of the region that I highlighted is listed in the begin time. The last part that I highlighted is listed in the end time, and they're plotted by these green dots right here. But I want to do better than that because I know it's got to be just when the force is 0. So it looks like the red circles are fairly accurate. So I'm going to click on the left red circle and scroll all the way over to the right red circle and click zoom in again. Okay, so that looks pretty good. If I want to shift this over, remember we know that this red circle is this value, 6.451. So I could actually adjust this, the beginning of the zoom, to be 6.451. If I hit zoom in again, it'll change that interval slightly. And you notice that the green dot is right on top of the red circle. Okay, so it looked like the red did a nice job to begin with. The red circles did a nice job to begin with. So I'm going to use that particular interval as the time that they're in the air. So to compute the jump height, given that time in the air information, I'm going to go to jump height options, and this is the default, but make sure it's checked, jump height using the 0 ground reaction force method. And then if you go to calculate jump height, it'll compute that value. So in this case, the jump height is 21.9 centimeters. And notice that it's listed here under our computed variables now. Okay, let's go back to the original graph by pressing original graph. And now I want to compute the jump height again and a few other variables by looking at the impulse information. So I'm going to highlight from right before the person starts to jump to right after they leave the force platform, and then we can make adjustments as needed. So I'll zoom in. Okay, and again, it looks like the automatic location where it picked with the red dot is fairly accurate. So I'm going to choose that again and scroll over to the second one. So that's going to define when a person started the jump to just when they leave the force platform. Zoom in again. And if you want to make fine adjustments, you could adjust it right here. So remember, in this case, this is going to be the begin of the jump time. So the red dot was 5.368. We just chose 5.366. I could change that to 8 if I wanted to, and do zoom in again. And actually, the other one's already correct. So the red dot was right when they leave the force platform at 6.451 seconds, and that's exactly what we chose, the green. Okay, so that looks good. So one variable we can compute is the impulse. So I'll go to variable options, calculate impulse, and then I'll choose calculate variable. So it gives you the vertical impulse is 178.7 newton seconds, and it's listed under one of the computed variables. And if I want to calculate the jump height now using the impulse momentum information, I can go to jump height options, choose jump height impulse method, and press calculate jump height, and it'll give me the jump height based on that information, so 21.7 centimeters. Another thing that I have it do, which is nice, is if I click on zoom in, right, once I've defined the area, it actually shades in the actual impulse itself, which is the area between the force curve and the body weight. If you want to get rid of that, you can do that by selecting other options and unchecking the fill plot, and then zoom in again. And by the way, if you want to get rid of the original events here by the red markers, you can get rid of those too by unchecking the plot event markers. And zoom in if you want them back. We can just click on that again. We have them back. Okay, there may be a few other things that you may want to compute. Since we have this region of when they begin the jump to right when they leave the force platform, the other thing that might be nice to compute is the power. Okay, so I'm going to go to variable options, click on calculate power, hit calculate variable, and notice it'll give me the peak positive power, peak negative power, and the units for both of these are in watts per kilogram, so it's relative to body mass, and also the rate of power development is 104.6 watts per second per kilogram. And when you actually compute the power, it prints out the power versus time curve. So this right here would be like the peak negative power, the lowest value. This would be the peak positive power, the highest value. And this rate of power development is going to be the slope from the lowest value to the highest value, the slope of that line that connects those 2 points. Okay, let's go back to the original graph. And then let's say we wanted to know something about the rate of force development. I'm going to highlight the region when the person is initiating the jump, let's say right there. And let's say I want to know the average force rate from when the force is at the body weight level to the peak force. So I'll select that region right there, zoom in again. So if I want to know the average force rate over that region, I simply go to variable options, click on calculate average force rate, calculate variable, In this case, it's 2,711.8 newtons per second, and it's added to my computed variables. And then if I want to know the maximum force rate, click on maximum force rate, hit calculate variable. It's going to be 5,435.8 newtons per second. And what that means is it's the largest slope between these 2 points. If you look in this whole entire interval, it's probably somewhere right in here. It's the largest slope that you're finding. Okay, let me go back to the original graph. Now, before you finish here, probably one thing that you're going to want to do is save the information from this particular trial, right? This particular jump. You want to save all these variables. So to do that, you would go to Save Variables, press Save Calculated Variables, choose a directory, and then give it a name. I'll call it Results New, let's say. If you don't give it an extension, it'll automatically give the CSV extension, so that's fine. We'll hit Save. Now, just to show you that those variables are there, let's actually load that file. So I'll go to my Windows Explorer, what I call it Results New. So click on Results New. By default, it's going to load Excel program. And then here are your results. So you have the name of the file, the weight, right, impulse, jump height based on the time in air, jump height based on the impulse momentum relationship, the average force rate, the maximum force rate, the peak positive power, the peak negative power, and then the rate of power development. Now notice, in this case, we calculated, those are all the potential variables we could have calculated. We calculated all of them. Had you not calculated some of these variables, you would just see a none in here. It wouldn't list the value, it would just have none. Okay, so let me get rid of that. Don't need to save that. Great, so that's about all you can do with that particular file. Now, if you want to look at another file, another vertical jump, you simply go to File, Load File, and then choose another vertical jump file. Let's say I want to look at a squat jump. It'll bring up that new information and everything. It'll start from scratch again. Great, so hopefully that was helpful, and I'll see you next time.